Today we are discussing about the mass flow rate. With the help of mass flow rate, we are going to solve the problem. Concept is mass flow rate. The formula for mass flow rate, m dot is equal to rho into velocity into area. We call as a mass flow rate. Mass flow rate, where rho is nothing but density, v dash is nothing but velocity, a is the cross sectional area, Let us consider a pipe inside which the water will flows and it will fall from the outlet. This is the inlet and this is the outlet. This is a timer in terms of second and a beaker above the weighing machine. That means we need to find out the mass flow rate. With respect to water. For example, 15 ml, what is the time taken? We are going to find out through the density of water. The density of water will be 1000 kg per meter cube. This is the density of the water. It is a standard. Okay, in order to find out the mass flow rate, this is the formula we are going to use it. Rho into velocity into area. Now, and mass flow rate always expressed in terms of kg per second. Now we know that density, this is the density. Density is nothing but mass by volume. Normally we will consider the mass as 1 kg. Normally we are considering as a 1 kg. Therefore, rho is equal to 1 by V. V is nothing but volume. Substitute here in place of rho, m dot 1 divided by V into V bar into area. It can be written as m dot A V bar divided by V. This is for the inlet. For the outlet, it can be written as A2 V2 bar divided by V2. This is the formula for continuity equation. We are using the mass flow rate and continuity equation for solving the problems. The formula stands for m dot is equal to A1 V1 bar divided by V1 is equal to A2 V2 bar divided by V2. Inlet and outlet here. Now here, mass flow rate is nothing but kg per second. Normal mass is nothing but kg. Mass flow rate is nothing but kg per second. We have to consider the time. Here we are not considering any time here. Now based on this concept, we are going to solve the problems. The problem is visible. Okay, now see here, this is the problem. Air enter an adiabatic horizontal nozzle. It is a problem of nozzle. It is a problem of nozzle. Air enter at adiabatic horizontal nozzle. If it is adiabatic, it is nozzle problem. Adiabatic Q will be 0, and W, work done, will be 0. In the case of nozzle, Q and W will be 0. This is the concept of nozzle. At the inlet, the velocity will be less. At the outlet, the velocity will be very high. But there is no work done and the heat transfer. Now the temperature is given at the inlet. T1 is equal to 400 degrees Celsius. We need to convert in terms of Kelvin. 400 plus 273. 400 plus 273. 673 Kelvin. With a velocity of 50 meter per second. Velocity is given. V1 dash 50 meter per second. The inlet area is given. Now here the area is mentioned, inlet area. That means this is the area 1 and 2. Inlet area A1 is equal to 240 centimeter square. Either you can convert in terms of meter square or it can be written same. The temperature of air at the exit are, now it is exit, outlet. Temperature is T2 is equal to 80 degrees Celsius. We need to convert in terms of Kelvin. 80 plus 273. 353 Kelvin. And given that specific volume at the inlet and exit are, specific volume is given. V1 is equal to 0.2 meter cube per kg. And V2 is equal to 1.02 meter cube per kg. Volumes they have mentioned. Find the area of the cross section at the nozzle exit. We have to find out the cross section at the nozzle exit, that is A2 we need to find out. Assume that enthalpy of air in the function of temperature only. Okay, now they are given Cp value. Cp is equal to 1.005 kilojoule per kg into Kelvin. Kilojoule per kg into Kelvin. Now, in the case of nozzle, normally we will find the velocity. V2 bar we will find. We need to find out the V2 bar. V2 bar here. Now, we know the formula as Q is equal to m dot H2 minus H1 plus V2 bar square minus V1 bar square divided by 2 into 10 raised to minus 3 plus Z2 minus Z1 into 9.81 into 10 raised to minus 3, close the bracket, plus W. Here they have not mentioned Z1 is equal to Z2. We have to consider Z1 is equal to Z2 because the heights are same with respect to datum. Therefore Z1 is equal to Z2. This becomes 0. And with the help of nozzle condition, Q will be 0 and W will be 0. Q will be 0, W will be 0. Q will be 0 and W will be 0 here. And they have not given any mass flow rate. Therefore consider as 1 here. 0 is equal to 1. Now H2 minus H1 can also be written as Cp into T2 minus T1. Now write it here. Write the Cp value. Cp is nothing but 1.005 and T2 is 353 minus 673 plus velocity V2 bar square minus V1 is 50 square divided by 2 into 10 raised to minus 3. Now we are going to find out velocity. Now use the calculator. On 0, alpha is equal to 1 into double bracket 1.005 into 353 minus 673 close plus velocity velocity alpha x square minus 50 square divided by 2 into 10 raised to minus 3. 10 raised to minus 3, close the bracket. Shift sol is equal to the answer for velocity is v2 is equal to 803.55 meter per second. We got the velocity. After getting the velocity, we need to find out the area. For finding the area at the exit of the nozzle, we have to use the continuity equation. From continuity equation, m dot is equal to a1 v1 bar divided by v1 is equal to a2 v2 bar divided by v1. We have to because they are given in terms of area, therefore consider only these two. Area 1 is 240 into v1 is 50, v1 bar square is 50 divided by v1, volume is 0.2 is equal to a2 is unknown, v2 bar we got it 803.55 divided by v1, sorry, it is v2 is 1.02. Now we are going to find out a2 with the help of calculator. Now see here how to find out. 240 into 50 divided by 0.2, alpha is equal to alpha x into 803.55 1.02. Shift sol is equal to, now you will get a2 is equal to 76.16 centimeter square because they are expressed in terms of centimeter square. This completes the problem. Any doubt in the problem? You have any doubt in the problem? Shall I move next problem? Okay, thank you. A centrifugal air compressor, 18 kg per minute of mass is given. Mass data, m dot is equal to 18 kg per minute. We need to convert in terms of second. 18 divided by 60, 0.3 kg per second. Next, the inlet and outlet condition of air are velocities. Velocities are given with in terms of inlet and outlet. V1 bar is equal to 5 meter per second and V2 bar is equal to 7.5 meter per second. Pressure of P1 is given 100 kilopascal and P2 is given as 700 kilopascal. Specific volume V1 is equal to 0.5 meter cube per kg, V2 is equal to 1.15 meter cube per kg. The increase in enthalpy, this is very important here. The increase in enthalpy of air passing through the compressor is 165 kilojoule per kg. That means the meaning is H2 minus H1 is equal to 165 kilojoule per kg. It is very important problem. See here, the condition they have given it, the increase in enthalpy of air passing through the compressor is 165 kilojoule per kg. That means they are given H2 minus H1. Directly they are given H2 minus H1. Otherwise, normally, ask the doubt. Okay, the final answer I have kept in, no, final answer I have kept in centimeter square only, no. No. See here, we are not cancelling any unit here. The final answer will be, if you want to convert into meter, you can convert it, no problem. You will get the same answer. You will get the same answer. Same answer. Now it is in terms of centimeter square. If you divide by 100, you will get in terms of point. In terms of point. Okay, you can cross check it. You can cross check it. Okay. Okay. Now, the increase in enthalpy of air passing through the compressor is 165 kilojoule per kg. In the normal problem, they will mention in this form. If they want to mention the enthalpy, they will express in 4 digit. They are expressed in 4 digit. Just wait, I will show the problem, other problem. In this way they will express it. There are 2 enthalpy they are going to mention it here. Normally they will be in terms of 4 digit. 4 digit. If they have given 3 digit, it indicates that it is a combination of H2 minus H1. It is a combination of H2 minus H1. Okay, if they have single value, they have mentioned it in terms of enthalpy. Therefore, you have to consider H2 minus H1. If there are 2 values are there, you can consider H1 and other to be H2. And the heat loss for the cooling is, the heat loss is given. Heat loss is given. Q is equal to minus 165 kilojoule per kg. Kilojoule per kg. The heat loss is mentioned in terms of kilojoule per, sorry, not kilojoule per, kilojoule per minute. We have to convert in terms of second. Q is equal to minus 165 divided by 60. Oh, sorry, it is 754, sorry. Q is equal to 754 kilojoule per minute. We need to convert in terms of second. 754, but it should be minus, okay? It is loss. It is loss to the surrounding. Divided by 60. Answer is minus 12.54 kilojoule per second. Now we have to find out in terms of HP. Whatever the output is obtained, work output, we need to find out in terms of HP. And one more, the ratio of inlet pipe to the outlet diameter we have to find out. That means we have to find out the ratio D1 divided by D2 we need to find out. D1 divided by D2 we need to find out. That is the ratio we need to find out here. Ratio we need to find out. Now let us find out the values with respect to, sorry, let us find out the answer with respect to work done. Work done. Because we need to find out here W value, the Q is given here. The formula is Q is equal to M dot, Q is equal to M dot H2 minus H1 plus velocity V2 bar square minus V1 bar square divided by 2 into 10 raised to minus 3 plus Z2 minus Z1 into 9.81 into 10 raised to minus 3, close the bracket, plus W. Now here it is a compressor, Z1 is equal to Z2, Z1 is equal to Z2, therefore it will be 0. The Q value is minus 12.54. M dot is 0.3. H2 value is H2 minus H1 directly they are given as 165, single value they have mentioned it, plus velocity 0.15 square minus 0.5 square divided by 2 into 10 raised to minus 3. Close the bracket, plus W. Now use the calculator and find out the answer. Use the calculator. Minus 12.54, alpha is equal to 0.3 into 165, close the bracket, plus 0.15 square minus 0.5 square divided by 2 into 10 raised to minus 3, close the bracket, plus alpha plus x, alpha into x. Shift solve is equal to here W. Here system is performing some amount of work to the surrounding. Therefore the negative sign is minus here. 62.03 kilojoule per second, or in terms of kilowatt. We need to convert in terms of HP. Don't consider negative sign. 62.03, 1 HP will be 0.735, because we need to convert in terms of HP. They have mentioned it here in terms of HP. Therefore divide by 0.735, 84.4 HP. Now we have to find out the ratios. We have to find out the ratio here, d1 by d2. We know the continuity equation. M dot is equal to A1 V1 bar divided by V1 is equal to A2 V2 bar divided by V2. We are using this 2. Now because it is in circular shape, therefore we have to consider, they have mentioned in terms of diameter, therefore area will be pi by 4 into d square. Now you can write here A1 A2 is equal to V2 bar V1 divided by V1 bar into V2. V1 has to move towards here and V1 dash at the down, and substitute the values. V1 divided by A2, it will be V2 will be V2 bar is 7.5, V1 is 0.5 divided by V1 bar 5 into V2 0.15. That means A1 divided by A2 is equal to 5. A1 is nothing but pi by 4 into d1 square divided by pi by 4 into d2 square. Area at the inlet and area at the outlet is equal to 5. This and this get cancelled. It can be written as d1 divided by d2 whole square is equal to 5. d1 divided by d2 root 5. The answer for root 5 is 2.236. This is the ratio. Any doubt regarding the problem, you can ask. No doubt? Okay. Next problem. Just wait. This is the third problem. A power capacity of system is, the power is given. Here power we are considered as a W here. Power normally we consider as a W here because it is expressed in terms of kilowatt. Data W is equal to 3000 kilowatt. For the following data, determine the fluid. We have to determine the fluid flow rate. What is the meaning here? Determine the fluid flow rate. Anyone? We have to determine the fluid flow rate. Excellent. We have to find out the mass here. The heat rejection is given as Q is equal to minus 100 kilojoule per second. The inlet velocity is given. V1 bar is equal to 300 meter per second. Pressure is given. P1 is equal to 6 into 10 raised to 5 Newton meter square. Newton meter square is nothing but Pascal. 6 into 10 raised to 5 Pascal. We need to convert in terms of kilopascal. 6 into 10 square into 10 cube Pascal. 6 into 10 square, and this become kilopascal. 10 raised to 3 becomes kilopascal. The inlet energy we have given it, that is U1 is equal to 2000 kilojoule per kg. U1 is given energy, inlet energy. Initial volume they have given it, V1 is equal to 0.4 meter cube per kg. The outlet velocity V2 bar 120 meter per second. The outlet pressure PT is equal to 1.5 into 10 raised to 5 Newton meter square. It can be written as 1.5 10 raised to 5 Pascal. We need to convert in terms of kilopascal. 1.5 10 square into 10 cube Pascal. 1.5 10 square kilopascal. The outlet internal energy U2 will be 1500 kilojoule per kg. Find the volume, final volume. Volume is given, V2 is equal to 1.2 meter cube per kg. Fluid enter and leave the system at the same level. That means Z1 is equal to Z2. Z1 is equal to Z2. Z1 is equal to Z2. We need to find out the mass here. Okay. Now we know the formula. Q is equal to m dot H2 minus H1 plus V2 bar square minus V1 bar square divided by 2 into 10 raised to minus 3 plus Z2 minus Z1 into 9.81 into 10 raised to minus 3, close the bracket, plus W. Here it will be 0. Now Q value is minus 100. M dot we need to find out. Before that one we need to find out H2 minus H1. Now let us find out the H2 minus H1. We know that H1 is nothing but U1 plus P1 V1. Substitute the value 2000. V1 is 6 into 10 square. V1 is 0.4. 6 into 10 square. 2240 kilojoule per kg. Now H2 is U2 plus P2 V2 U2 value is 1500 plus P2 is 1.5 10 square into V2. V2 is 1.2. You will get answer as 1680 kilojoule per kg. Now we can substitute in the above equation. Minus 100 is equal to m dot is unknown. H2 is 1680 minus 2240, close the bracket, plus velocity 120 square minus 300 square divided by 2 into 10 raised to minus 3, close the bracket, plus W is 3000. Now find out with the help of calculator. Now let us see how to find out that part. Minus 100, alpha is equal to alpha x, double bracket, 1680 minus 2240, close the bracket, plus 120 square minus 300 square divided by 2 into 10 raised to minus 3, close the bracket, plus 3000, shift solve is equal to, the answer is m dot is equal to 5.18 kg per second. Any doubt regarding the problem, you can ask. Okay, shall I move for the next problem? No doubt. Shall I move for the next problem? Okay. In a gas turbine unit, the gas flows through a turbine at a rate of, data is given, rate m dot is equal to 15 kg per second, and develops a power at a turbine, W is given 12,000 kilowatt. The enthalpy of gas at inlet, enthalpy at gas at inlet and outlet, they have mentioned at H1 1260 kilojoule per kg, and outlet is 400 kilojoule per kg respectively. With the velocity of gas at inlet and outlet, velocity is given V1 dash is equal to 50 meter per second, and V2 dash is given as 110 meter per second. Now we have to find out, first one, rate at which the heat is rejected, that means Q we have to find out. Next, second is area of the inlet pipe given area of the inlet pipe given that specific volume of the gas at the inlet is V1 is given as 0.45 meter cube per kg. We have to find out the area here. We have to find out the area at the inlet. We have to find out area at the inlet. Now Z1 Z1 and Z2, they are not mentioned it, therefore Z1 is equal to Z2. Now substitute in the values. You know how to find out the Q value. Q is equal to m dot H2 minus H1 plus V2 bar square minus V1 bar square divided by 2 into 10 raised to minus 3, Z2 minus Z1 into 9.81 into 10 raised to minus 3, close the bracket, plus W. here it becomes 0. Q 15 400 minus 1260, velocity 11 square minus 50 square divided by 2 into 10 raised to minus 3 plus 12,000. If we calculate, Q will be minus 828 kilojoule per second, because it can be calculated directly. Minus 828 kilojoule per second. We got the first part. Second is we need to find out the area. M dot is equal to A1 V1 dash is equal to V1. A2 V2 dash is equal to V1. Let's go with these two, because we need to find out the area. Mass is given. Mass flow rate is given. Now 15 is equal to V1 dash is 50 divided by V1 is 0.45. Now use the calculator for finding A value. 15 alpha is equal to alpha x into 50 divided by 0.45. Shift solve is equal to A1 value is 0.135 meter square. Any doubt regarding this problem? The last problem for today's session. This is the last problem. It is very important problem. A centrifugal pump delivers 50 kg of water per minute. M dot is equal to 50 kg per second. The inlet and outlet pressure P1 is equal to 1 bar. It is converted into kilopascal. 1 into 10 square kilopascal. And P2 is given as 4.2 bar. 1 into 10 square, 4.2 into 10 square kilopascal. Now section is 2.2 meter below the center of the pump. There is a center of the pump. There is a pump here. Their height is given Z2 and Z1. Therefore, the section, this pipe is below the main motor. Therefore, we have to consider as negative sign. Z1 is equal to minus 2.2 meter below the center of the pump and delivers to the 8.5 meter above the center of the pump. Therefore, Z2 will be 8.5 meter above. Consider as a positive. The section and the delivery of the pipe diameters are, diameter is given, D1 is equal to 20 centimeter. We need to convert in terms of meter. 20 divided by 100, it will be 0.2 meter. Next, 10 centimeter respectively. D2 is also given 10 centimeter. We are converting in terms of meter. D2 is equal to 10 divided by 100. It will be 0.1 meter. 1 meter. Determine the capacity of electric motor. We need to find out the W value. And we have to find out the efficiency. Now here we have to find out W, and the efficiency is given as pump efficiency. That means we can write as neta pump is equal to 85%. That means 85 divided by 100, 0.85. We have to determine the capacity. Power required supplied to the motor, we need to determine it. Now W we need to find out. It's the concept of centrifugal pump. In the centrifugal pump, some conditions are there. The conditions are nothing but U2 minus U1 will be 0. This is very important. Internal energy with respect to in the centrifugal pumps are 0. And there is no heat transfer occurs. Q will be 0. Q will be 0 here. And the volume with respect to inlet and outlet will be equal. That means volume is nothing but the water. It cannot be compressed. Therefore, we are considering V1 is equal to V2. V1 is equal to V2. And the volume, we know that volume is nothing but mass by density. Mass by density. Mass by density. Here, the mass is we are considered as a 1 and density of the water we will consider as a 1000. Then the volume becomes 0.001 meter cube per kg. Now here V1 is equal to V2 because water is incompressible. Incompressible fluid. Because water is incompressible fluid, therefore V1 is equal to V2. V1 is equal to V2. Now we have to find out the velocities here. Velocities in volume we got it. We need to find out the velocities. How to find out velocity? We know the continuity equation. M dot is equal to A1 V1 bar divided by V1. Substitute the values. 50 is equal to area of the pipe. 50 is equal to area of the pipe pi by 4 into d square V1 bar divided by V. 50 is equal to pi by 4 diameter at the inlet 0.2 square. Velocity we need to find out. Volume is given as 0.001. Use the calculator for finding the velocity. 50 alpha is equal to pi divided by 4 into 0.2 square into alpha x 0.001. Shift solve is equal to V1 1.59 meter per second. We got velocity here. Now we are finding the V2. M dot is equal to A2 V2 bar divided by V1. 50 is equal to pi by 4 into D2 square V2 bar divided by V. 50 is equal to pi by 4. D2 value is given as 0.1 square V2 bar we need to find out divided by 0.001. Now in place of 0.2 we have to substitute 0.1. Shift solve is equal to, you will get V2 bar is equal to 6.36 meter per second. 3.36 meter per second. Now after getting the velocities, substitute in the actual formula. Now before substituting the actual formula, let us go finding H2 and H1. H1 is nothing but U1 plus P1 V1 and H2 is nothing but U2 plus P2 V2. For H2 minus H1, it can be written as U2 plus P2 V2 minus U1 plus P1 V1. Further, U2 plus P2 V2 minus U1 minus P1 V1. Now make it this side U2 minus U1 plus P2 V2 minus P1 V1. As it is a centrifugal pump, we have to consider this as a 0 condition. The P2 value is P2 value. The P2 value is 4.2 into 10 raised to square, and V1 is 1 into 10 raised to square. And VV, what is the V value? V value is 0.001. Substitute here. Substitute. (4.2) 10 square. V2 is 0.001 minus 1 into 10 square into 0.001. If you calculate, the answer is 0.32 kilojoule per kg. After getting the answer, substitute in the formula. Formula stands here. Q is equal to m dot h2 minus h1 plus v2 bar square minus v1 bar square divided by 2 into 10 raised to minus 3 plus z2 minus z1 into 9.81 into 10 raised to minus 3, close the bracket, plus w. Now substitute the values. Here the Q will be 0 with respect to condition. 0 is equal to m dot. M dot value is 50. This is a 50 here. 50. H2 is 0.32 plus velocities. Velocity is 6.36 square minus 1.59 square divided by 2 into 10 raised to minus 3. 10 raised to minus 3. As Z1 is equal to Z2. They are given the Z1 values here. They are given the Z1 values. Substitute here. Substitute the Z1 values. Plus Z2 value is 8.5 minus of minus 2.2. Close the bracket into 9.81 into 10 raised to minus 3. Close complete bracket plus W. We need to find out W. Now use the calculator for finding W. 0 alpha is equal to 50 into double bracket 0.32, close the bracket, plus 6.36 square minus 1.59 square divided by 2 into 10 raised to minus 3 plus, open the bracket, 8.5 minus 2.2, close, into 9.81 into 10 raised to minus 3, close the bracket, plus alpha x. Shift solve is equal to, the answer is W is equal to minus 22.19 kilowatt. That means system to surrounding, the work is done. Negative indicate that system to surrounding, the work is done. Now further we have to convert in terms of efficiency. Therefore power supplied to the motor is written as W is equal to neta pump efficiency. 22.19 divided by 0.85. It gives 26.105 kilowatt. This is the efficiency of the pump. This is the obtained result with respect to motor. That means, see here, in the normal case, From surrounding to system we will consider as a W, minus W. From system to surrounding we will consider as a positive. Here from system to surrounding we are doing it, therefore it is negative sign. From surrounding to system we have to consider as a negative sign. Efficiency divided by efficiency, you will get the power supply to the motor. This is the power supply to the motor. Any doubt regarding the problems?